All right, for this one, we're going to solve for x as well. So we're going to look at a couple parts of this shape right here. And remember, the idea is that we're looking to make a triangle. We're looking at this one right here. And so what I'm going to do is I'm going to take this side length right here, which I know is 3. And I'm also going to look at, well, we'll say this side length right here, which is 1. Okay, now it's important that we have this information down. In order to find the length of this x, which is the hypotenuse for the triangle that I'm looking at right here, right? So remembering that this red length here is 3 and this green one is 1, what I can do is take this red length right here and just move it up right there. And then I know that this red length is 3. Now the problem is, right now we have this whole side length, which is 3. But what I know is if I take this green side length and move it here, it had a value that was 1, so that's going to be 1, which means that the rest of that side length here, altogether it was 3, but we used up one of them, which means that the rest of it would be 2. Okay, so this 1 side length and this 2 side length totals up 3, which is the full side length right there. Now I have my right triangle here, which I can solve for. And in fact, if I wanted to, I could take that bottom part, just in case if it's in the way, I could get rid of it. What I'm going to do, though, is I'm going to split it off. So this is the triangle that I'm looking at right here. And we're solving for that x side length right here. So I drew that by hand, so of course it kind of stinks right there. But what we have up here at the top, of course, is our Pythagorean Theorem, because we are looking at a right triangle. Again, I'm pretty much ignoring what I had in the beginning, because this triangle right here is the same as this triangle, which we have made. So from there, we have one of the legs of that right triangle is 2. The other leg is 3. And then what we're looking for is the hypotenuse. I'm just going to keep that as hypotenuse. I mean, you could write in an x right there, but I'm not going to do that. So now I have leg squared plus leg squared equals the hypotenuse as a square. Now what I'm going to do this a little different. Okay, so what I'm going to do, I'm going to take both sides right now and square root both sides. So I'm going to square root the hypotenuse to the power of 2. And then I'm going to show you that you can do this directly in the calculator. So I'm going to push second x squared. So that's going to give me the square root button on my calculator. And on the calculator would look something like this. And then as I type values in, it's going to get longer, but I'm going to write 2 to the power of 2 plus 3 to the power of 2. It's going to make so I can skip a lot of that, a lot of the work here. 2 to the power of 2 is 4, 3 to the power of 2 is 9 kind of stuff. And then once I get that solved, I will have just the hypotenuse in the end, which is what I do want from this. So square rooting both sides, it's going to make so we can skip some of that work. Here's what my calculator gave me. So it's a pretty nasty decimal, and it's okay to have a decimal answer, but as it turns out in this problem, what we want is the answer in simplest radical form. So this is where a TI-30 XS multi-view would come in pretty handy. And if you do, you're going to get the square root of 13. Pretty much, all you do is take 2 to the power of 2, which is 4, 3 to the power of 2, which is 9, 4 plus 9 is 13. So if you need to show that work, that's fine. 13 is prime, so this cannot be simplified any further, so there's no need to worry about this simplified radical form business. We have that hypotenuse, which is, you know, if you wanted to show that as x, you could as well. But square root of 13 is what we're looking for on this one.